And that moves me on to the next point. Rare earths are, contrary to their name, they're actually not rare, and they crustal abundance. They're abundantly available in our crustal abundance. And there's a lot of potential deposits out there. However, to win a sustainable winnable material, that becomes the problem. So rare earth deposits that are economically viable is the question, and that makes them rare in that. And we've spoken about this in previous updates. We looked at a few key considerations to consider before we went into picking up projects. And one of them was the 2 stages of the metallurgy. Can we win a product, a high quality product that is amenable to be sent to various potential off-takers at that point? And if we answered that, then the second question was, what was the cost of that product, of winning that product, environmentally, as also processability in terms of what CapEx would be required to win that. Then we looked at, if we are able to win those products, what radionuclides would be contained in those products. Because we're looking at monazite, majority of monazite deposits have got a high thorium content with them, and majority of them are actually heavy mineral sands deposits. And due to norm standards and shipping standards that they are in, if we were dealing with a product that had a high radionuclide content in it, it would severely undercut the people that we would be able to sell any of our product to. Secondly, if we weren't able to split or crack those products, and I am speaking in layman's language here, into separated minerals or metals at that stage, those products would never be of any viable source to anyone, because ultimately manufacturers of neodymium magnets need a metal. They don't need the ore, they need a metal. The people in between that need to be able to separate your individual metals out of your hosting mineral, which is in our case monazite, in order to produce the metal that the manufacturers require. And Eureka is unique in that point. Because of our large-scale monazite, we can use simple off-the-shelf gravity separation that allows us to produce a mixed rare earth concentrate that would be of 60% TREO, which is almost to imperial value, and is the highest basket value at the moment. If we look at the prices that various groups are using, they're sitting in somewhere in between 8,000 to 9,000 at the moment, what various off-takers are paying for mixed TREO concentrate.
That's US dollars. 8,000 to 9,000 US dollars.
The second thing, which is extremely nice, is we are able to, because of our low radionuclide content, we're amenable to shipping the product with a low radioactive level. We're below what would require any special shipping or concentration level. And compared to other competitors at the moment, majority of the people that we are in discussions with can produce a metal from this. So we not only have a product that's easy to win, we have a product that's very, very attractive to multiple parties. And we have been in conversations, and we continue to be in conversations with these groups as we walk through it. And here's a simple illustration to why large-scale monazite is an effective or a very attractive deposit. And it has to deal with grabbing sweets out of a tin. If you have small, complex assemblaged grains of weathered carbonatite, it has a complex processing requirement. And that complex processing requirement is basically breaking out monazite, which holds the value, from everything else that is with it. Our unweathered carbonatite, as we have at Eureka, can use a very simple, high recovery processing technology. And that leads to a lower cost in our flow sheet to get into production. Yes, right now we're only talking pilot production. We are busy working with various groups into understanding how to work all the way through this to produce a product in the short term. But we are also comparing ourselves to other projects within that space. Size is not king. Grade and recoverability and processability and final product is the king. And definitely, you know, for the next couple of years, we as a company do see that the volatility in supply in the rare earth market is going to continue to lead to a supply increased demand, which will definitely lead to price. There is money flowing towards R&D, and as well as understanding the processability of recycled stuff. But in the short term, there is quite clear that there's a shortfall in future demands. And if you're able to produce a product quickly that can be sold to multiple people and that is attractive without any of the issues, that is going to be of attraction in the short term. Just to explain a bit of the value chain of the rare earths, and just to add where we as the company see some value. Right now, we've done studies and we're busy working through putting in exactly what I've just demonstrated to you, a simple gravity concentration and beneficiation plant that would produce a mixed rare earth concentrate with about a 60% TREO value. We would have the ability to send that and sell that to multiple off-takers. There's also an ability to potentially move to the next step, which is, we've got it here as cracking, but it would be the next step of potentially looking at a separation through various solvents to get to a higher neodymium praseodymium oxide, which is the next step up of the value chain, which obviously attracts a lot higher prices. That is where the company currently is busy working with various parties and groups and engaged with various contractors and understanding what makes the best sense economically for the company and how do we want to move this forward. We know that we have 310,000 tons at 4% TREO that we could get into production relatively shortly. And we also in discussions with various groups regarding the product that we could potentially produce from that pilot production in that time. The second thing, which is the third thing, which is also very important for us, is we are in a jurisdiction that has got a very clear and transparent mining and environmental code, but also has been desensitized to to minerals that have got radioactivity associated with them. And that is due to the fact that 100 kilometers down the road from where we are located right next door to two of the world's most substantial low-grade uranium deposits. We are in discussions with various stakeholders right through from local to federal government on how these processes can be put in place. And we're also in discussions with various other stakeholders and governments worldwide to understand how this will get into production to start fitting some of that supply gap. I've got a question here. How much would it cost to put a pilot plant into production? Right now, the studies are ongoing. We started the studies a couple of months ago, simultaneously while we're also doing exploration and also simultaneously trying to understand the product that would be most beneficial to our stakeholders and our shareholders. If we understand the pricing and understand where we're going to fit in on this value chain as I'm presenting to you, the cost would obviously change as we upgrade the product that we're going to be producing at the end of it. So that's the exciting part of where we're doing. We're definitely an exploration company exploring for more tonnage. At the same time, looking at the short-term ability that we have in our back pocket to get a pilot producing project going and produce a product that would be amenable and attractive to multiple off-takers.